Hello, good morning or good afternoon, everyone. Let's sound check. Let's make sure I got everything going here for you guys. Let's see here. I've got a couple things. Got a meter. Got the meter going. Meter going. Let's see here. Web page. Just a couple things we're gonna go over today. Hey Jesse. Hey, thanks for joining in with us today. I'm just been trying to get things set up here as usual. So, as everyone probably reads, as noticed in the title, we are just going to be covering a Class AB amplifier today. I don't do a lot of repair videos on AB amplifiers. I do a lot of Class D amplifiers, so every now and then I do get an AB in, and I get a lot of questions on AB amplifiers. So I'm going to try to help go over some of the questions that have been building up on me today. So as you can see, I do have a screen up for general information of a Class AB amplifier. And then of course the board that we're going to be going over today is an older board. It's the Optimus. I think this is a Radio Shack, released by Radio Shack, I think, many years ago. I think that's where I've heard of Optimus. It's been a long time, but it's a really simple layout design of this amplifier. So that's why I chose this to go over. Hey George, hey, thanks for joining today. That's why I decided to use this amplifier to go over today with some, not only the repair of this, but the education point of Class AB amplifiers. I like amplifiers that are laid out in a way that is easy to understand. So, and if I can help relay the information to others, then I feel I have done my part in trying to help people understand the topology of these circuits. And of course, with every amplifier, you have two sections. You have the power supply section, all right, over here on this side, the two transformers. Then you have the output section. The power supply section is fine, operates perfectly. So there's not much to go over about the power supply. I mean, I can go over the basics with you. You know, they're the IRFZ. I do think this is using the 44s. On the power supply transistors, it's got two separate supplies, which is good. I like to see that also. And it's probably running a standard frequency. Let me just double check the gates here real quick. And I don't have my scope up for you guys quite yet because I do have my meter running, so bear with me on that. So this is running at a little higher than a standard one that I'm used to seeing, at 38.7 kilohertz, roughly a 4.5 volt amplitude on the gates. So a little higher frequency than I'm used to seeing. This is using the SG3524 IC to drive the power supply. Oh, hey, just, actually, I just answered that. Yeah, I thought originally when I first opened this up, it would be a 494 based, but it's not. It is the SG3524 based power supply on that. Again, just a really simple topology on the power supply, not much to get confused here about. We're going to have, looks like, two IRFZ 44s for each side of the transformer. And then, of course, you have your rectifiers. The 12 C20s, common anode, common cathode rectifiers. And then, of course, you have your output stage. Then the outputs are using the A1516s and the 3907s, the C3907s. Just kind of an older design here. And again, I always like to point out the easiest way to know you have a Class AB amplifier is the emitter resistors here. So these white squares are emitter resistors. They're low value resistors, which is the telltale sign of a Class AB amplifier. Now please keep in mind, guys, that I do use just generic terms that hopefully everyone understands, because I don't know the knowledge base of everyone that comes and watches the channel. So I kind of try to keep things as simple as possible. So the two primary things I wanted to go over on this board is the driver, the output drivers. As you can see grouped over here, you got your little TO92 size transistors all nicely laid out. So that's your drivers for your output transistors. And then I also wanted to go over the output protection circuit. And when I asked the customer to send me a picture of this board, I knew right off the bat where the protection transistors were. And I can point it out right here. There's one, and here's one over here, and here's one over here. Over time, you just kind of get used to seeing the layout of these kind of circuits. And you'll find that these this group over here, this diode, this transistor, and these two resistors, you'll find a trace that goes back to the emitters of each channel. And then they all link together to go back through, I can't remember which one it is. It's either this gray wire or this yellow wire here, which goes back over to a transistor Q2 right here that shuts down the power supply. But when we flip this over, we'll go through on how to locate that protection circuit coming off the emitters of each channel. But this amplifier does have a fault. One for sure fault, and one fault that I'm going to call it has a leaky driver. This is what I'm going to call it. So that's what we're going to repair today. This amplifier uses the 733s and the 945s on the drivers, which I'm going to just temporarily replace. What am I going to? I was going to use the 3198s and its equivalent, just to go over the repair of this board. So as you can see, I do have the meter up on the screen. So sorry guys, this is in diode mode. I know, one of the few settings I ever use. So it's going to beep at you. So hopefully it's not going to disturb you too much. I'll try to keep it away from the microphone. So as I was moving around this board here, let me change my direction here. I noticed that we did have a pretty large discrepancy between these two channels on the back side, the input side of these drivers. And for the people that wondering the path of the signal, so the easiest way to explain that is that your signal will come in through your preamp and it'll pass right through this electrolytic capacitor. And again, that's a real common layout in Class AB amplifiers. Your signal will first go through a capacitor. This capacitor then comes over here and feeds this TO92 transistor here on each one. So there's a capacitor here that feeds the beginning stage of the drivers. So I did notice that the emitter and base right? Emitter, collector, base. Yeah, emitter and base. So we have forward voltage of 0.68 volts for Q24 over here. And then I have a forward voltage of nothing over here on Q26. So what I'm going to do is just check a channel. These two channels back here work. These two channels, this channel doesn't work, and this channel has got a little intermittent issue. So what I'm going to do is I'm going to just check a transistor over on the good channel. For its forward voltage. If I can get my leads. So 0.68. Oh, some of these amplifiers, they twist these TO92 transistors around and end up shorting those legs out sometimes. 0.67. So this turn leads around. So this transistor over here, Q24 0.68, is good to go, but Q26 here, not so much. So I know right off the bat that I'm going to have a problem with this first driver here. So let's see, let's get the scope going. All right, so I've got scope going now for you guys. I just want to show you on the scope what this is doing. So I do have my 50 hertz signal going in on the input. As usual, I always use a 50 hertz signal. All the crossover points, everything is fully counterclockwise. Sometimes techs will give me a call and say, hey, I don't have any signals going through the preamp. Well, I was like, then I'll ask them, well, is it getting crossed over, crossed out? What frequency are you using and where's your crossover set at? So I use 50 hertz and I turn all the potentiometers all the way fully counterclockwise. That really eliminates the issues of having your input signal being crossed out is what I call it. All right, let's see if we can trigger on this thing. So there's the base of this channel of both the NPN and the PNP output transistor. It's a BJT, so you can see that that base is not correct. And then the channel next to it, I mean, it does have a sine wave, but if you notice the sine wave, it's not very clean. So the emitter follower on those is also something to take a look at compared to the two good channels on the backside of the amp. Those sine waves look great. These two, need a little help, especially this guy. And that automatically points me back over to the drivers back here. And then you can always check the input from your preamp, again, at these capacitors. So as you can see from the preamp, I do have a signal coming in from the preamp. On both channels. And it doesn't have any steps in it or anything, so I know from the preamp it's good. So you know that the issue is going to be in the drivers. And to get a better understanding of those drivers, we're going to go ahead and point you to a page that I kind of refer to a lot to help explain things. is this learnaboutelectronics.org. So if you want to get a good general overview of how the Class A/B function works, how they call them complementary matched pairs of transistor emitter follower mode is what this is, and how that's used to drive this Class A/B amplifier. This is a great resource to use to get a beginning idea of how these amplifiers function with the drivers. And once you understand the NPN and PNP basics of the drivers, then you start to learn of how you end up with these odd signals at the bases of the transistors. So it really does come down to understanding the function and how an NPN or a PNP transistor works. And that's why I wanted to point you to this page here. It's great reading, push-pull drivers, Class B, Class A. You have everything from amplifier circuits to power amplifiers to op amps. It's just a great resource to start digging into the Class A/B amplifiers. And then, of course, we have that web page right there. You'll probably hear me through my videos mention Perry's Guide to Amplifier Repair. This is probably one of the best resources you can get if you're new to the amplifier repair world, is Perry's Guide. This is his free guide that's online. It's at www.bcae1.com. And let's see here. You can read some pretty general stuff here. He does have a lot more information if you buy his full tutorial. And he does go through a lot of the information on how amplifiers work. So I just wanted to point out his tutorial there for you. So I'm going to go ahead and remove the drivers on the bad channel first. Let me turn off my power supply here. And go ahead and flip this thing over. Now the board is identified in what direction they go, which is good. And these transistors have the, it's emitter collector base on the transistors. So you really can't go wrong when putting a new transistor in, as long as you make sure you read the data sheet of the transistor they're using and that it has the same pin out. So I'm just going to flip it over and I'm going to identify the transistors I'm going to be pulling out. And I'm not bashful. I will use a Sharpie to mark what I'm doing. And let's find the other side. I think I'll go ahead and pull the other side while I'm here. Sorry for the glare on that. So I'm gonna fire up the good old Hacko, the 301 here, the desoldering tool. And let's go ahead and test these transistors and see what we got. So I'll pull out the transistor tester. I don't use these testers as a what would you call it? The final say in transistors. This is just to tell me if it's good, bad. HFE 322. That's 683 millivolt. So let me check the other one. If I was successful at desoldering it. Maybe not so much. There it is. All right. $338, $628, 2.1 milliamps, NPN. Keep getting one leg. All right. So again, these are the drivers that drive the output. Then I will take my meter and just double check the rest that are in front. 5960, 6061, 5922, 64, and finally 59 and 0. And then we're just going to keep working our way back, pulling these drivers out of here. Because what I'm going to do is I'm going to replace all the drivers on this. I'm sorry guys, yes, I do have dogs. So for anyone that's wearing headphones, be aware that I do have dogs. Alright, so that'll take care of all the drivers. Of the emitter followers. So that's good there. I'm going to go ahead and fire the amplifier back up and check to see if the amplifier signal on this channel here is still, what would I call it, acting up. Okay, it's got a little, yeah, so the one of these drivers is leaking just a little bit, and that's crossover distortion, I think is what they call that, which you can read again on that website that I had pointed out about the class AB. I think this covers crossover distortion. That website right there. I think if you dig into that, you'll see that you'll run into crossover distortion explanations on how you see that little bit of a glitch in that sine wave there. That's crossover distortion. And then I'm going to check my incoming signal again, coming into the bad channel, which is still good. If you guys could see what I was doing there. So there's the signal still coming into the bad channel. So I do have a good incoming signal. So let's grab some transistors here. So PNP, all right, so PNP, there's the PNPs, and then I got to grab some NPNs here, A733. And we'll go ahead and put that channel back together. All right, we're going to go ahead and turn that off and reinstall some transistors here. So hopefully you all are having a great weekend so far. It's Sunday, so kind of a quiet day. I was gonna do a video yesterday, but I got tied up on a Smart 5 that was completely destroyed. And I didn't do a video because I know Sam just put out a video on a Smart 5, so A lot of people that watch my channel, they do watch Sam's channel, so I didn't want to bury people in Smart 5 stuff. Hey Sean, hey, good to see you here. Just fixing amplifiers. I know I tell everyone I try not to work on Sundays, but I didn't get around to a video yesterday because I was fighting the Smart 5, so I figure I'd get one done today for you guys. So while we have this flipped over and my iron's heating up there, I'm just going to go over the protection circuit uh, for you, if you can see it. It's going to be kind of hard to see with this glare. Let's see, get down in there. Let's see what I can do for you guys here. Kind of hard to see. So you'll see these little traces coming off the emitter of each channel. And if you follow this little trace that comes off the emitter, you'll find that they come back to a resistor, it comes back to two resistors, and then eventually it hits a transistor here. And this transistor will go back to the diode, keeps your voltage flowing in one direction, and they all come back to a common trace. So that's what I look for when I find that an amplifier has a protection issue. If you've gone through and you have a power supply, you know it's functional, it's working right, but as soon as you start an amplifier, it goes into protect, check your output protection circuits, which again will be a trace usually tapped off the emitter trace somewhere. And most times they're pretty obvious. Even on newer boards, you'll find a via that's tapped right into the output, the emitter. And if you follow that trace back, so this one here comes around, goes around, and goes to this transistor here. This one comes around, hits a jumper, goes back around, and they combine here at this trace. This emitter here goes around, goes to this resistor here, goes to this transistor, then goes to this diode. And you can see that all these emitters go back to a common trace, which is right here. And this trace jumps over and goes back over to the power supply. So if any one of those transistors fail from a shorted output, then the amplifier will go into protect every time you fire it up. Who makes this amp you working on? Oh, this is the Optimus. This is an old school Optimus amplifier. I do believe it was Radio Shack brand back in the day. And I know a lot of people will say, well, the amp's not worth fixing. But you know, with my business, it's the customer's amplifier. If they want an amplifier fixed, I'll fix it. It's not my decision to, you know, tell someone that their amp isn't worth fixing. I will let them know though that they, you know, if you are in the 60% of retail cost, that you know you're approaching the not economical to repair the amplifier, it may be better to buy a new one. But if a person wants their amplifier repaired, I will never question if it's worth fixing. I will just let them know that they are approaching that 60% threshold of not economical to repair, because it'd be cheaper to buy, well, not say cheaper, but it would be more beneficial to buy a new one compared to repairing it. You know, as they say, a repaired amplifier is never 100% the same. So And that's how we go around and just solder these drivers back in. Now, I didn't pull the, what would you call it? Last stage of the drivers. I didn't pull those. So you'll find in these Class AB amplifiers that if you pull the drivers and you still have a problem with the sine wave, you may want to keep going down the line, because one of these drivers will drag your signal down all the way back. So sometimes you can find it with diode mode of your meter, and sometimes you can't. It's really, really hard to find a leaking transistor. And what I mean by leaking is each transistor is basically a junction of diodes, 2 junctions, 3 junctions. And sometimes those junctions will leak. They'll pass current or pass voltage when they shouldn't. So I call those leaking transistors. And that leaking transistor is what causes the issue down the line of your drivers. But again, on this type of board where it's really laid out pretty simple, it's easy to see what is doing what. So you have a positive rail and you have a negative rail. And if, again, going back to this website explains, kind of explains how the NPN and the PNP transistor follows that current path. I think Perry does a lot better job at explaining those things over here on his website when it comes to understanding the principles behind an NPN and a PNP transistor, those BJTs. So it's a great resource to have. Sean, have you ever thought about building amps? No. Building, oh my gosh, if there was more than 24 hours in a day, maybe, but to be honest, the repair industry is it's huge. It's bigger than what a lot of people really can comprehend. It's bigger than I ever thought or imagined it would ever be when it comes to repair of automotive amplifiers. So I do my best to help educate others to become good techs, because here in the near future I'm going to be looking for some good techs. So but building amplifiers, no, I will leave that up to the corporations and companies that have the money to pay engineers to try to think of a new design. You gotta remember too, these amplifiers, they've been using the same topology for years and years. Nothing has changed. They've made things more complicated, but it's doing the same thing. You're taking an analog signal, turning it into a square wave or a digital signal. Technically, the word digital and amplifiers really don't mix, but that's what it is. It's the same concept, just doing it in a different way, in 100 different ways. But yeah, Sean, that's a great question. Thank you for asking. Time is what everything comes down to. That's why I'm doing this on a Sunday. Let's see here. On a 4th of July weekend, which I know is going to be kind of hard to know if people are around to even watch the videos, but we'll see. All right, so now as you can see, since I have replaced the pre-drivers, we now have a perfect sine wave on the scope. And I can go through and show you, let's see here. Do I have a wider view? I really don't have a wider view. I can show you these transistors in my hand, I can show you that on a meter, and that meter will not show, this meter right here will not show that any of these are shorted. And it also didn't tell me that any were leaking. It does, some had a little bit more current than others, but which one? Which one of these was the culprit that was leaking? Well, it was the one that I was reading on the meter that had 0 forward voltage. That's the one I would suspect. But otherwise, you really don't know. Replace them all. That's what I usually do. Do I have my other camera up and going? Let me show you guys. Do I? Oh, I do, but you really can't see. I have a whole different scope setup that I have a DIY curve tracer and a Tektronix scope all the way back on the other corner of the workbenches here that I use to match driver transistors. So for the sake of today's repair video, I just plopped in new drivers to show you that you can find the problem using diode mode on your drivers, replacing the transistors and making the channel functional again. So, but in reality, what I would do is on the new transistors, I would run them on the curve tracer and match those before I put those in. Would a transistor curve tracer say that? Yes, it sure would. Great question there, Jesse. Yes, a curve tracer will show you that. But, you know, there comes a balance between firing up all your equipment and I don't know, how would you put it? Firing it all up, setting up your gear just to see if you have a leaking transistor, when you already know right off the bat, based on what the transistor, the base of the transistor was showing you, you knew that you had a leaking transistor somewhere. And if you replace one driver, it's always best practice, in my opinion, to replace its neighboring drivers. So it's where you want to, you know, how far you want to get down in a rabbit hole of testing and matching or finding a leaking transistor. So that took care of one channel, but let's take a peek at the other channel that is giving us a little bit of a headache here. I don't want to say a headache because it's really, really minor. Let's see if I can zoom in on this here for you guys. So if you notice on that sine wave, it's I wish I could point you with a mouse on what I'm trying to show you, but it's got a little ridge in the sine wave. It's not perfect. That is borderline of a transistor that is just slightly leaking. So you have a little bit of crossover distortion in that. So is it the bias transistor that's doing that? No, because remember, your bias transistor, the little transistor that's sitting right in between the two primary output transistors, that is just going to control your bias based on the temperature of the heatsink or the transistors that are neighboring it. So I don't believe that that's going to be a bias transistor issue. I think it's going to be a driver issue. So that's the channel we just repaired. And now this is the channel that I personally am not happy with that sine wave. Can you think we can find it by digging around in the drivers? Let's check and see. So again, your signal comes in here at the capacitor. It comes around and it enters the first transistor, your first driver. And this one here, of course, is reference to your positive rail. So you have a good sine wave going in, and my scope is set at 10 volts per division. So we're going to go ahead and go down to 2 volts per division. Notice how clean the sine wave is not. Now that goes into filtering. That's the design of the circuit. So that's not my scope. That's just how this circuit is. So just let you guys know. So we do have a good sine wave coming into it. Remember, it's reference to the positive rail. There's the sine wave coming out. There's the sine wave coming in, reference to your negative rail. And there's your sine wave out. Now, if you noticed something between the NPN or the PNP transistor that I just checked, what did you guys notice about the output of that transistor? Yes, yes, exactly. More for a hi-fi matching pairs. Yes, indeed. That's when you get into the real finite fine-tuning of the output stage. Let's see what a transistor curve. Do transistors go bad because of heat? Yes. Someone's car alarm is going off. Huh. Sorry about that, guys. Let's see here. Do transistors go bad because heat? Yes, they do. They can fail over time. Yeah. I have two tech spectrum only, and one works. I get both for free, but never have used them. Two Tektronix? Yeah, the perfect. Hold on, guys. It was just someone their car alarm going. Yeah, if you wanted to get into the matching of drivers, get yourself one of those DIY curve tracer kits. They're great little kits. They're not that hard to put together, and as long as you have a good analog scope, you can do your curve tracing all day long. So where was I? Oh yeah. Did you notice the output of the transistors? Now see this one here, how we are hovering below the zero reference on the output, and this one here is right center, I should say. It's even between the positive and negative. This one here, we're hovering a little low. And then we're going to come over to the next transistor here. And then the out. And I can just start to see the little hump in the sine wave there. Where is it? Let's see here. Can I point it out? Kinda. It's kinda hard to see. If it had a little cleaner signal. Let me see if I can find it here. Whoa. So I think it's going to be, so there's the input. There's the output. And since it is I can just barely see it. If I had a cleaner signal, it'd be a little easier to see, but it doesn't have a cleaner signal. So you can just barely see the crossover on it. So in my opinion, the best thing to do, oh, hold on. Oh, oh, here's something. All right, guys. Let's see. Just based on temperature, I was just feeling the temperature. These primary drivers here, the last part of the stage, they're they're cold. It's cold as can be, but the channels that are functioning, they're actually warm like they should be. No thermal runaway, right? Make sure I don't have any thermal runaway. Ah, yeah, so did these get... I'm going to go ahead and replace... Let's see here. This is the A1358. Did they get changed? A1358? No? Huh. Yeah, I don't feel any heat coming off those. Oof, but we do have some crossover distortion here. So I think it's, again, it's going to be the best thing is to replace the drivers. I'm kind of curious of why the final stage is so cold, though. Oh, it's here. Let's do it. Turn the power supply back off. One of those is bad, but I'm really starting to question the final drive. So the customer did state that one output transistor was replaced, or one or both. Both output transistors have been replaced. So I don't know originally if the outputs were shorted, which if they were, would have more than likely damaged the final stage of the drivers. But we're going to find out. These little TO92 transistors, they're dirt cheap. So there's no huge cost. Of course, unless you don't buy things in bulk, there's no really huge cost in replacing the drivers. So let me identify the transistors. Which are going to be there and here and here and here. And as you see, if you guys notice, I don't mind drawing on boards at all, but if you look right here, looks like some corrosion or something happened. So I have it identified here that I got to fix a ground path. The trace coming off the primary, the negative ground, negative power, that comes around and grounds the amp to the case, that trace is gone. It didn't burn up, it looks like. Looks like it got corroded away. I'm not sure. But I got to repair that to have a good ground back going back to the case. All right, let's pull these drivers out of here. If I can get the right... There we are. And if this doesn't solve that crossover distortion, then you know we're going to have to replace the final stage of those drivers. Which I don't know if I have a direct replacement for those, or if I even have those on hand. So some of these older amplifiers, you either have to find the equivalents for, or stock, new old stock transistors. All right, so let me get these pulled out of here. There, that's all your drivers. And again, of course, I can put all the drivers through the tester, but that won't show me if one's leaking. And what I'm seeing is a transistor that's leaking. It might be a little slow, might have a little, yeah, it's hard to say. Leaking, it could be between any of the junctions in that transistor. So I know I have a good signal coming in. I'm not quite so sure about the final stage of the drivers, but again, we will determine that. So right off to the side here, I lay the I have my little foam mat here. I lay the transistors out and kind of stab them in place, and I just lay them next to each other to keep things in line. What could be causing the 15 voltage regular zener and adjacent transistor to excessively overheat on the power side of a class AB? Because a 15 volt voltage regulator, zener and adjacent transistor to excessively overheat on the power side of a class AB. It's going to be a short, that's for sure. But remember too that the voltage regulator, depending on your rail voltage and the resistor across it, it's going to drop a significant amount of voltage. It's going to have to dissipate a lot of power. Again, depending on your rail voltage. But when it comes to voltage regulation, usually I see the resistors overheat first if there's a short. Or you could have a bad zener. You'd have to set your zener up on a 1 kilo ohm resistor or a variable power supply and test and see where the breakdown voltage is of that zener. So I'm just going to double check to make sure I have my NPNs and my PNPs correct here. So that's a PNP. And I just want to make sure I got my PNP correct. I don't want to put drivers in that are backwards. Yeah, all right, good. So let's get the new transistors in. Current base emitter of 703 millivolts. So them are a little high. That was the, I was just testing the one that came out, so might have a little bit of leakage. But that's what we're looking for, is we're going to eliminate the transistor that's leaking on us. And again, if this does not solve that problem, then I have a sneaky suspicion that the final stage of the driver might be damaged. Something is off, or there's just not a lot of bias current or something, because those final stage drivers are not heating up at all. And they should, because most of those final stage drivers, they do tend to run pretty hot on these Class ABs. So we're going to find out. But I have a feeling it's going to be a pre-driver. So hopefully none of these fall out. Nice. Fire up the Hacko again here. Yeah, and then after this, I do have a Tar Amps MD, is it a 12K? MD 12K that I'm going to be doing. If you guys want to stick around for that, you feel free, but it is an inductor that, I don't want to say came loose, but it's the typical common failure of the trace burning out at the inductor, and then hoping and crossing your fingers that it didn't damage anything else on the board. Let's see here. Hey, it's Cardi Cardi. Hey, thanks for joining. How's the weekend going for you? Oh yeah, for sure. Yeah, that's the thing is, uh, I don't care about the value of a customer's amplifier. What I care about is make sure the customer's happy. That's really what everything's about. A happy customer is a returning customer, in my opinion. So I do everything I can to make sure they're happy. And that's what, that's why it comes down to making sure your repair work is good quality, clean. You really, impressions on customers are really key for them returning. Oh, and guys, for all the guys that are familiar with my website, keep an eye out. I have a new website that's being designed that is in the process. It's for the most part done. It's being in the process of being transferred. The domain is being transferred right now, so I'm waiting patiently for them to finish the transfer. But I do have a new website coming that's going to be hopefully a little bit more user friendly compared to the Wix website that I had. Hopefully I don't get knocked for saying Wix isn't bad. It's just not very user friendly when it comes to being able to modify the content. I have to do a lot of work to be able to change the content in the site. So I went with a designer who is using, I do believe it's WordPress, and I will be expanding the available parts at the storefront. And I will be providing available new, catch this guys, new plastic ends for most all Tar Amps amplifiers. So I will be carrying those. So keep an eye out. Anyone that uses Tar Amps or ships Tar Amps or really uses them knows that those plastic ends tend to break. So I will be carrying those. They're on the way. They're en route. Good. Glad to hear that you're doing good there, Cardi. Keep up those good videos too, guys. Hey, if you everyone go check out his channel. He's another guy that I watch. He can be pretty funny too. So he'll probably make up for my lack of funniness. Let's see here. The real voltage about 30 volts. Thing good feedback. I'll check out for any shorts. Yeah, voltage regulator circuits. Typically, if it's a 15-volt regulator, it's going to be powering your preamp most times. Yeah. So if you have a short in your preamp, you will start to have problems with your voltage regulators. So I would check your preamp if that's what that 15 volts is powering. But you said it's on the power supply side, so, well, which makes sense. If you follow the traces back, you should see that it's going probably back to a preamp, or if it's like an Orion design, B2 uses it also, going back for some auxiliary power. you'll find that there. So where was I? Oh, drivers are in. Are they in the right direction? Hopefully I'm not getting myself sidetracked and putting things in backwards. All right. So let's go ahead and power this board back up again and see if it's a pre-drive issue or a final stage drive issue. Oh, it helps if I put a signal back into it too. So let's go ahead and get a signal put back in here. I was like, hold on, there's no sine wave, but did I put a transistor in backwards? All right. There's another guy I've been working with too that has an amplifier, and I was talking to him about making sure his transistors aren't in backwards. So, and as you can see there on the screen there, guys, in the upper left-hand corner, just by replacing the pre-drivers of the drivers. I know, so you got first stage, second stage, third stage of the pre-drivers here. Oh, and finally, there we go. Now I'm getting some heat on the final stage drivers. That's exactly what I'm looking for. And as you can see now that sine wave is perfectly in line. There's no crossover distortion on that sine wave. So the emitters all come back to the center of the board and go to this plug right here in the middle. So I'm just going to check to make sure that my sine waves are clean and accurate at the plug. Hopefully, if I can get down in there. Can't quite reach that far with my probe here. Those are down in there. Let me get over here on the terminals. Oh, I think we have ourselves a bad plug. Or maybe not. Because where is my orange? It's there. All right. So somewhere around here I gotta find. So there's 1, 2, 3. Where's my 4th channel on the end here? So 1, 2, 3. All right, come on. Let me undo my plug here. One, 2, 3, 4. Okay. Yeah, so one of these plugs, one of these wires is not making it. Oh. Oh, it helps if I'm on the right screws. Sorry about that, guys. So I do have all 4 channels, and you can also check out your emitter resistors too. That you have good sine waves at your emitter resistors, which I have no complaints about those sine waves. And again, I'm using a 50 hertz signal. So you should see it on the scope there, 51.5 hertz. Yeah, okay. So my signal generator is 1.5 hertz off. So well, Todd, that sounds good to keep up the good work. Or I wish I could start selling some replacement parts too, like ICs and MOSFETs. Yes. Yes, guys, I am working on that. I'm not working on the website. I hired someone to do it. So he does have a complete new storefront that is being integrated into the website. So I do carry, I mean, I don't want to say thousands of parts, but I carry several hundreds of different parts that I plan to make available for other techs since things are in super short supply right now. So I want to make sure I don't have any thermal runaway. You'll read again on that website that you can come across issues with thermal runaway on Class AB amplifiers. This website right here, again, it's learnaboutelectronics.org. These Class AB amplifiers use a bias circuit based on temperature to help regulate the bias current. So the first thing I do with Class AB amplifiers when I take them out of the heatsink and I power them up is I fire up my thermal imager. I power the amplifier and make sure I don't have any output transistors that are going into thermal runaway. They will fail really quick if you get into runaway. So that is the essence of repairing just a real standard, simple Class AB channel. Just to go through the fault process, if you lose a primary transistor, you will more than likely lose the drivers behind it that are driving it. Because there's really nothing between here and here that limits the current going back to your pre-drivers. There is a resistor, brown, red, orange, whatever value that is. Sorry guys, I don't have it memorized. The color chart I did probably 30 years ago, but I don't know. So there is a resistor, but again, I don't think they're there to limit the fault current going back. So that is a Class AB amplifier for you, with references to Perry's website and some literature on the workings of Class AB amplifiers. Again, I do highly recommend Perry's stuff here to help educate others about amplifier repair. Perry's great guy. Perfect, that sounds good. I can't wait. Yeah, yep, same here. It's almost done. Like I said, we're just waiting for the domain transfer to be complete, and then we are going to work on the fine details of the new website. So business has gotten so big that I had to do something different with the website. And since my Hacko iron is still up and running, I'm just going to do a quick repair of the ground trace. That seems to be missing. Now this is how I do trace repair, minor trace repair, I should say. Old transformers have many great uses. This is a winding off of an old transformer that had of course, primary, secondary, and it had a feedback. So for all the people that understand power supplies, you have your flyback transformers that, you'll have your feedback winding. So you have 3 different sizes of copper in this. So this is a ground path here. So I'm going to use probably the thicker of the wires to repair this trace. Now these wires, they are lacquered quite heavily because it did come from a transformer. but I use just little pieces of sanding discs here from my Dremel tool. Little 220 grit paper, and I just strip away that insulation of that copper wire. Just like that. And now I'm going to solder that copper wire into place. Maybe. See if I can do this without burning my finger. And then I'm going to bend it, follow the path. Cut it to length. Solder it in place. I'm going to put a little bit of flux on that to help the solder flow a little easier on that wire. Use my tweezer, push it down. Just like that. Then of course you're gonna use some isopropyl alcohol, get rid of the flux. Because what I'm gonna use next doesn't stick very well to flux. So we're just gonna clean the flux up here. With the trusty Q-tip. And then my all-time favorite glue to hold the traces down. Gorilla Glue Clear Good. I buy this in the 3-pack. This stuff, when it dries pretty hard. It's still a little flexible, but it is pretty solid stuff. And it sticks to almost anything. I use it to glue windings down on noisy transformers. And I'll use it for minor trace repair where I don't use my epoxy base. Just like that. And that's how, I mean, it's a ground trace, so I mean, it's nothing real critical when it comes to the aesthetics of the amplifier. It is underneath the board. Of course, if you wanted to be real good, you could use some green conformal coating to kind of bury that or hide that back in the original color. But you can see that someone had taken this blue wire here and jumped from here to here to complete that path. So I guess, you know, someone already knew that that trace was missing, but why didn't they fix the trace? I don't know. I'm not a huge fan of that because that could affect, I don't know, the inductance of some paths. No, what is that? That's going back to your rectifier. So we'll just leave it at that. So that's that amplifier for you. So if anyone has any questions, just please feel free to leave them down below for me. I will answer them the best I can when I can. Again, that's just a overview of the repair of a Class AB amplifier for you. Just a general idea of the workings of it, and some resources to help point you in the direction to understand how the sine wave goes from a positive to a negative in reference to 0 volts. So positive rail, negative rail, and how they use NPNs and PNPs to swing that signal above and below that 0 reference line. So I thank you guys for watching. I will be out with another video. I will get a tar amps inductor repaired here, and hopefully get another video put up for you guys. So thanks for watching. If you guys have any questions, leave them down below. Keep your fingers out of the rails. Stay safe.